Welcome to the program. This is the Ecomodernist channel live. We're here with Matt Wald. Matthew is an independent energy analyst and writer. He was a reporter for over 38 years at the New York Times, where he covered climate, energy, and other subjects. He was also a policy analyst and communications consultant for 6 years at the Nuclear Energy Institute. And we were just having a wonderful discussion about artificial intelligence goes nuclear. One of Matthew's writings earlier this year in thebreakthroughjournal.org. Do you want to go over it?
Sure.
In your words? That would be wonderful.
Artificial intelligence can optimize energy production at nuclear plants running now, and it can assist in the design of new ones that are still on the drawing board. What impressed me is work they're doing with boiling water reactors already in service. We all learned that a reactor runs for 18 months or 2 years. You shut it down, you take out a third of the oldest fuel, move the other fuel towards the center, put newer stuff around the edges, start it up again, and go again, and then replace another third. It turns out that's an oversimplification. Some of the fuel bundles don't last through 3 cycles. You take them out after 2 cycles because they don't have enough oomph left in them to run another 18 months or 2 years. And you end up throwing away some of their energy value. It's like replacing the batteries in your flashlight before they're really dead. But you need the flashlight to be working so you don't worry about it. So AI can figure out how to design a core, how to put enough reactivity into each bundle, enough U-235 into each bundle by varying the enrichment. It can design a core better than a person can, and therefore reduce the number of bundles you need, make sure they all last as long as they're supposed to, reduce the volume of nuclear waste. There's also work going on to make boiling water reactors run better. There's one case in which a reactor, the control room operators noticed that the flow of neutrons seemed to be increasing. Neutrons are the subatomic particles that keep the reaction going. And it looked like it was going to exceed its license limits, and they were getting ready to insert control rods to slow it down. And they ran it through an AI analysis that showed that the devices inside the core that send back data that tell you about the neutrons were inconsistent. And the reason is, of the dozens in the core, several had gone bad, and they were giving faulty readings. Humans didn't spot this, AI did. They turned off some of the monitors and got a better picture of what was going on in the core, continued to run without inserting the control rods, continued at full power, avoided lost production. There's also work going on in designing reactors. The fabrication of new reactors could be different. Some of it can be done with 3D printing, where you get a computer-controlled device that lays down layer after layer, building up a structure. And among the structures you can build is an entire core in a graphite-based reactor. We think in a graphite reactor where you use an inert gas to carry away the heat, we think of the cooling channels as like tube-shaped, like drinking straws or something larger, being straight and predictable. But it turns out you can get more power out of the reactor if they vary in diameter and vary in shape. And you can build that with 3D printing, but you got to design it. And it turns out that AI can design that for you. Now, AI is not perfect, and it occasionally gives bad answers. This certainly requires lots of human input. And as we move forward, it will require a lot of human supervision because you don't want to insert something unpredictable into your process. But I think the next frontier for AI is probably going to be streamlining maintenance and operations at current reactors. You can send a human engineer out into the field, have him snap a picture of a component, upload it. AI looks at it, knows what the component is, knows when it's supposed to be serviced, knows based on past experience that maybe we should service it sooner or maybe we should delay and service it later because we know what the failure rates are, knows what parts you're going to need, what parts are in inventory, what has to be ordered, what manpower is going to be needed, and then schedules it, gets it on the calendar, gets it all set up to go. This is not HAL 9000 spooky stuff. This is just optimizing what's out there already, but it could be helpful. It could help cut costs and make nuclear more competitive.
I appreciate the idea of having a second brain or an expert system to sort of be a companion to an engineer or a technician, try to avoid mistakes, try to avoid duplication of effort. But the concern is, of course, that if we release too much control to machine learning, to language models, to these complex systems we don't understand, that we'll have sort of either a crisis of competency or a crisis of quality control. What's the resolution to this?
All of that is true, but you presume that we understand what we got now. At San Onofre, where they are preparing to go for extended operation, extend their license, they counted up, they got thousands and thousands of procedures, which are printed in books, stored on microfiche. They want to consolidate all of this so they understand what they got. They want to rationalize it. The Nuclear Regulatory Commission has this enormous database of all its documents, and it's unsearchable. You can't Google it because Google works by looking for connections between pages, between documents. This is not linked to anything. So there are two companies, Microsoft being one of them, that are downloading this entire corpus and setting up links. So it's not going to take over running your plant, but it'll be a more effective way of seeing what the NRC has done in previous cases, what it's licensed, what it's approved, what it's disproved, how applicants convinced the NRC to do X and Y and didn't convince them to do Z. And I agree with you. We got to approach this with caution because the AI people refer to something called hallucinations. You may have seen the newspaper story that was in the New York Times about the reporter who was chatting with AI, and AI told him to leave his wife because his wife didn't really love him, and then goes off on this extended hallucination. You don't want that to happen in a technical field. It was kind of fun in the newspaper, but you want to keep a close eye on this. And AI already gives bad answers, but they're obviously bad.
Right. And to double check you, I think that's Diablo Canyon is entering extended operations.
I'm sorry. I'm sorry. Yes. Yeah.
Unfortunately, San Onofre has been
It
already
has
cut
been
apart.
decommissioned. Yeah.
But yeah, we're definitely, everyone here is really excited to see Diablo Canyon continue to operate safely. And I think you're absolutely right that having technicians who are, spending their time learning the systems and learning the documentation on the job is a bit of a risk, and any acceleration to that is going to, accelerating their training or facilitating having a reduced level of experience is definitely a positive. We can't wait 20 years to grow a new generation of expert engineers. We need to backfill that information in some way. And so, again, the skeptics out there are going to sort of reinforce, how do we know that these are the right decisions? And your response was just now, well, we're not even doing a good enough job now.
That's correct. We do inoptimal stuff all the time, and we're certainly not going to let computers run things. We're going to use these as assistants. But if you think about it, you get on a modern jet airliner, there's a computer that is monitoring all the functions and calling those to the attention of the pilot. We already rely on computers for life-critical high-tech operations to flag what's going on, to call up appropriate instructions, to make recommendations. We don't do much of that in the nuclear area, and it still requires human intelligence, but it can be an assistive technology.
Maybe this is a little bit outside your expertise, but you mentioned AI is very good at figuring things out and suggesting things. You just need a good engineer to go in and look it over and kind of give an approval of these plans that would have taken us many hours, perhaps hundreds of hours, come up with. AI did in maybe 1 hour, and we should follow these. But do you have a sense on how this will affect employment for the number of engineers we have? We need experienced engineers to monitor the output of AI, how do we get experienced engineers in the future when all the young ones are relying on AI?
To some extent, it will change what engineers do.
Mm-hmm.
Already there's training for engineers to come up with prompts. How do you phrase the question you give to the AI so it'll solve the problem? Some of the displacement will not be among engineers. It'll be among the inventory control people. It will cut the paperwork requirement. It'll streamline things. We will need more nuclear engineers, not in direct proportion to the increasing number of reactors, I think, because the reactors are going to have to be standardized. But we will need more engineers, and some of them will have different skills. But at this point, I think there's a job in the nuclear industry for anybody who wants one.
Mm-hmm.
I can't disagree there. I know that I'm trying to grow my own team. I hear lots out there. People are hungry for employees who are committed to the task. A great analysis in the tech sector was that there's possibly 10% of engineers who are effectively ghosts at work today, who do not produce sufficient output to even justify basically the air they breathe, let alone their position in a physical office. And unfortunately, it looks like this means that all of us are coming under more pressure to perform, whether or not we are literally a ghost programmer, a ghost engineer. Are we going to be in the panopticon watched by AIs? Are we going to have to be so paranoid that every flick of our wrist is going to be monitored?
I think most of what gets watched by AI is other computer components, is devices that monitor pressures, flows, temperatures, vibration, etc. And it's going to look for patterns. It's going to have a better memory than we do. It's going to put its experience to use, and it's going to call on humans to take corrective action.
Mm-hmm. Yeah. And I think to reinforce that, I know that AI is not, it's not literally a creative force. And that's the big value that human beings add to the engineering process. You will be able to use an AI in order to devise a proof, a mathematical proof, but it will have thousands of times more steps than is necessary. And it really takes a human mind, at this time at least, in order to distill an idea to its purest form. And then we retrain the AIs and we iterate on that. We iterate on these language models and expert systems in order to guide the next generation of engineers.
Yes, we iterate on that, but we also iterate on the problem at hand. You rephrase it, direct the AI in certain directions.
One of our contributors said they had to fight just to get an interview. The industry is very selective about who they hire, and so I guess this is sort of reinforcing a high quality standard for the caliber of engineers in the nuclear industry. And so maybe this is pulling us back from the idea that we will just be listening to the machines all the time.
The overall employment picture in nuclear is that, having gone for years without having built new plants, the workforce is getting older, and it's going to turn over. One segment of that workforce is engineers, a lot of good jobs among highly skilled technicians. And there's a big market there too.
You wrote that information technology has shown us the ability to make industries more efficient, but others will criticize energy growth on the basis of Jevons paradox or induced demand. And so the idea is that a cheap commodity will increase consumption of that commodity. Is that where we're headed? Like, the more we invest in AI and nuclear and industrial growth in these systems, are we going to end up using a bunch of essentially wasted energy?
I don't think we'll waste it. I think if it has an economic niche, we will use it. If you are Amazon or Microsoft or somebody else using AI or selling AI services to the public, energy is a small portion of your expenses. Hopefully, it'll stay a small portion of your expenses. And companies will do this to make money, and they will offer amounts of AI that the market will accept and pay for. And capitalism will work this out to be a rational level of AI capability and use. Look, I'll give you the opposite case. Solar cells have gotten really cheap. As it happens, this has not moderated the demand for solar, and we're now putting out lots of solar panels, and the solar goes to waste. I don't think AI is going to be in that category. We're not going to have vast amounts of AI that go unused, churning up megawatts of electricity as it goes.
Well, there's always, a bit of criticism as AI displacing labor. I hope that for one we're headed to a future where this makes the average human being more productive in their creative endeavors.
More prosperous.
Yes, more prosperous.
I've got a typewriter under my desk. I haven't used it in years. The computer made me more productive. Connecting my computer to the internet made it yet more productive. I'm sure the last typewriter shop of which I am aware in my city closed some months ago. Yes, there was displacement, but the world got to be a better place.
Matt, do you have any projects that are upcoming? Anything that you'd like to plug or tell us about?
I am watching with great interest the incoming administration. I do have something that will be published in the next few days on some pro-nuclear and anti-nuclear organizations, and their identities would surprise you. And watch this space. If you Google Wald and Breakthrough and Substack, you will find it all.
That's really fascinating. I used to have a hobby of opposition intelligence on this topic, so I'll be excited to see what you've uncovered.
This stuff is out in the open, but lost in the flood of information, and it's surprising.
Yeah. Thank you, everyone, for your contributions. This has been the Ecomodernist channel live. You can find us every Sunday at 10 a.m. Pacific, 1 p.m. Eastern, right here on YouTube at Ecomodernist1 or the Ecomodernist channel. You can find us on twitch.tv/Soyaddle or soyaddle.tv. For the moment, I think I'm going to continue to broadcast this on x.com/CarlAlexPauls, and you can find us on Facebook at the Ecomodernist Society of North America. Please support us on Patreon. Look for the Ecomodernist channel on patreon.com. And please find us on the web at esna.earth. That's ESNA.earth. I'll see you next week, and remember, emissions first, peace and justice will follow.
Please subscribe to us on YouTube, Ecomodernist channel. Also to subscribe to us on Twitter and Facebook, Ecomodernist Society of North America.
And online at https://esna.earth.